Hey everyone, and welcome. So today we're going to do something a little different. I'm basically cracking open my personal study notes for the Cisco AITECH exam. The idea here is for us to kind of study together, focusing less on just memorizing facts and more on getting into the right mindset to actually understand the stuff.
Okay, before we properly dive in, we have to get the important legal stuff out of the way. So here we go. This is an independent, unofficial Cisco AI Tech study presentation run by AI hosts. It is not affiliated with, authorized, sponsored, or approved by Cisco. Always verify important details against the latest Cisco documentation and course material. All right, with that said, let's get into it.
So let's start with the big question you should ask before any CERT exam. What are they really testing for here? Because, it's never just about if you can remember a bunch of random facts. There's always a deeper logic to how these questions are built.
And here's the answer. The AI Tech exam is not trying to turn you into a PhD-level machine learning researcher. Its real goal is to see if you can think and act like a capable, hands-on, technical practitioner. It's about good judgment in the real world, not just abstract theory.
And that whole idea of being a practitioner, that's everything. It's the mindset you need to adopt to pass. Honestly, if you can learn to think this way, you'll find a lot of the questions just start to make sense. So let's break down what that really means.
Okay, principle number one, useful AI is structured AI. A really well-designed workflow with good context and good data retrieval is always going to outperform just a vague one-off prompt, even if you're using the most powerful model on the planet. In a real business, structure beats raw power every single time.
Second, and this one is so important, enterprise use means controls. When you're looking at a question and you're weighing the options, the one that adds a layer of privacy or a security check or an approval gate for a human, that is very, very often the correct choice. We're not just playing around here. We're talking about deploying tools responsibly inside a real company. This also means that the model itself is only one piece of the puzzle. The best way to think of it is the model is just the engine, but the car also needs a chassis, wheels, brakes, the tool it's wrapped in, how it's deployed, the controls around it. That's the rest of the car. The exam is testing if you see that whole picture, not just the brand name of the engine.
Oh, this is a huge one. It is so easy to build a quick demo that looks incredible. But is it ready for production? Is it observable? Is it supportable when it breaks at 2 a.m.? The exam will consistently favor the answers that show operational maturity over just a flashy, fast prototype.
And finally, think of AI as an amplifier. It takes whatever you give it and just cranks it up to 11. If you have a solid process and good judgment, it'll make you faster and more effective. But, and this is a big but, if you feed it bad data or flawed assumptions, it will amplify those mistakes with scary speed. The human is still in the driver's seat and still accountable. Okay, so we've got that practitioner mindset locked in. Now, let's get practical. How do we turn that into a smart study strategy? None of us have infinite time to study, so we need to put our energy where it's going to have the biggest impact. If you look at the official exam weights, it tells you a very clear story. You've got 3 big domains: generative AI models, dev and workflow automation, and agentic AI. Each one of those is worth 20%. Do the math, and yep, that's 60% of your total score right there. The exam blueprint is literally telling us where to focus. So here's a really simple way to attack this, a 3-pass approach. On your first pass through the material, just focus on those 3 huge domains that make up 60% of the exam. Nail those down. On your second pass, you can solidify the next 2. And then on your final pass, you can cover that last, smaller domain and do a full review of everything. All right, let's get into some of the technical details. There are a few key concepts and distinctions that come up again and again. Getting these crystal clear is essential for applying that practitioner mindset correctly. First up, the classic RAG versus fine-tuning debate. Here's the absolute simplest way to think about it. You use RAG when the model needs to know more stuff, like your company's latest internal wiki pages. It's a knowledge problem. You use fine-tuning when you need the model to behave differently, like always adopting a specific personality or always outputting in a perfect JSON format. Know versus behave. Next, cloud-hosted versus locally hosted models. Look, there's no single best answer here. It's always a series of trade-offs. The cloud gets you started fast and gives you access to the newest, most powerful models, but you have to be really thoughtful about data control. Hosting it locally gives you maximum control over your data, but now you own the entire infrastructure headache.
Answering a question on this means picking the solution that matches the business priorities in the scenario.
Okay, let's talk about agentic AI. It's really easy to get lost in all the hype, but the clearest distinction is this. Generative AI produces content. It gives you an answer, a summary, a chunk of code. An agentic system, on the other hand, pursues an outcome. It reasons about a problem, it calls tools, it looks at the results, and then it decides what to do next to get closer to its goal. And this brings us right back to our core mindset, right? As soon as you have a system that can take action on its own, it absolutely has to have constraints. In a production environment, an agent without guardrails is a huge liability. You need things like timeout limits, token budgets to control cost, retry limits to avoid infinite loops, and most importantly, approval gates before it does anything that can't be undone.
So what's this Model Context Protocol, or MCP? The best analogy I've ever heard is that it's basically like USB-C for the world of AI. Right now, every model provider has their own unique proprietary plug for connecting to tools. MCP is an emerging standard to make that connection universal. The goal is that any compatible model can use any compatible tool without a ton of custom code. It's all about fixing the fragmentation problem.
Okay, finally, knowing what to do is only half the battle, right? You also have to know what not to do. So let's quickly cover a few of the most common traps to watch out for on the exam.
Here are a few big ones. First, don't confuse the tool with the model. The tool is the application, the model is the engine inside. Second, always remember that checking the license is a critical step for any business use. Third, don't automatically assume that local deployment is faster or cheaper. It comes with a lot of operational baggage. And last but not least, never ever forget to put an approval gate in front of an agent that's about to do something irreversible.
So, we've gone through the mindset, the strategy, and the key technical concepts. When all is said and done, what's the one big idea you should have in your head as you click that Start Exam button?
It's this. Treat every single question like it's a real operational problem you need to solve for a real business. When you're looking at the choices, just ask yourself, which one of these is the most practical, the most secure, and the most controlled? That's the practitioner's answer, and that's the one that's going to get you through. Good luck.